Hey there, Next Attack is here. In this video, we're going to go over how to validate if a file is of a specific file type, and we're going to do this in 3 different ways. But the common ground here is we're going to look at the first couple of bytes and last couple of bytes of a file just to see if it lines up with well-known patterns. For example, if we take a look here at this little list that I put together, JPEGs and JPG files, which by the way are both exactly the same format, they just happen to have different extensions, they all start with these 2 hex bytes over here, which is FFD8, and it ends with FFD9. Whereas with PNGs, they all start with these 8 bytes over here that we see, and then also something like a gzipped file, a GZ file here. Yeah, that starts with 1F8B. This is not limited to images. And of course, if your application happens to do something else where maybe you're dealing with GIFs or bitmaps or other file types, there's different values that you can find just by Googling and checking things out here. And I will say this, we're going to be going over 3 different ways to do it, and all 3 ways happen to run in constant time, which is really nice. It means it's going to be very efficient. So for example, if you have a JPEG that's 20 kilobytes or an MP4 file, like a 20 gigabyte video, then we're going to be able to look at even the last couple of bytes of that video in the same exact amount of time it would take to read the first couple of bytes of a smaller file, which is nice. But yeah, let's get cracking here. And I actually prepared a couple of little scripts that we're going to go over here and some JPEGs and PNGs. And all this will be linked on a blog post in the description if you want to go and check it out. Feel free to, not have to stop the video and start typing like a maniac if you want to get some of these things done. Now, yeah, we are going to go over, and by the way, the Python and Ruby version is very, very little amount of code. Even if you don't know those programming languages, it's going to still be pretty easy to follow here. We're basically talking 1 or 2 lines of code. But yeah, we're going to be breaking down these commands a little bit more too, as we go here to just see how they all work. But yeah, the OD command, the octal dump command here, let me just go and run the script first so we can see its output here. We can see here that we are getting a couple different outputs here for a little bit of some scripts that I wrote here. But yeah, if you just run the first command here, OD, it actually takes in a couple of parameters. Now, if you've watched some videos in the past, I do like using the long flag names. I feel like they're more descriptive here, but they happen to not work on macOS or basically the BSD version of OD. So we are using the shorthand flags here. The longhand flags are over here. So T is format and capital N is the number of bytes that we want. So in this case, we just want to look at the first 2 bytes of this python.jpg file, which is sitting on disk here. And we can actually see that, yeah, the first 2 bytes of this file start with FFD8. And if we go back to that notes file here that we were looking at before, yep, there's a JPEG here, and it starts with FFD8 here. And also, spoiler alert, it ends with FFD9, and yeah, it lines up over there. So let me push this out of the way so it's not bothering us here. But yeah, that's basically how that works. And, if you run, and by the way, this T flag is different formats. This gives us the hex values like this. We can run it with X2 instead here, and we can see the difference in output here. In this case, it basically does something very similar. I don't know the specifics of different hexadecimal code formats here, but just by looking at the outputs, right, it seemed to have flipped them and also got rid of the space there. So I think X1's a little bit easier to read, a little bit more intuitive, at least for this use case here of just wanting to look at the first 2 bytes or last, whatever it happens to be. So yeah, this little code here is the first output that we see here. And by the way, I do have links to all this in the description, but this is the man pages for OD. There's all sorts of different formats that you can set here. You can have octals and decimals and hexadecimals and, whatever you want that's supported here, that's pretty nice. Yeah, maybe you don't want to have hex, right, as the output, maybe something else. Cool, so you can do that. And yeah, now let's take a look here at just getting the first 2 bytes, because, if you look at the output here, there's all sorts of different things here, right? This is padded by some value, which I actually don't even know what that is off the top of my head here. But yeah, the hex values that we really want here, if we were to look at this, is like, well, we kind of just want the first line of output, and then we want to just get like the second half of that basically. So that's what we're doing here with this pipe command here that we're doing. So if I just grab this and we run this command by itself down here, then we can see that we are just getting the first line back. Well, let me just make sure we can all see things. Yes, we can. But yeah, this head command here is just going to give us the first line of output here. And then we can just cut that to get a little bit more specific. And when we do that, then it's like, yeah, let's actually cut this by spaces because that's what these are. And then we'll just go and get, the second one onwards to however many there happens to be. So in this case, there's only 2 of them, so it's going to get all of them. But that's what the dash does at the end there. So if I just did this, we're going to get FF back, which is the second one. But no, we actually want the second one and everything else. So we can do that. Or we can even flip it and go, the second one and everything before that. I've actually done more videos in the past around just using cut, so you may want to go and check those out if you're interested. I'll leave a card up. But yeah, let's go back to just running this OD script here, and now take a look here at the first 2 bytes. That's what we just put together here, and that gives us the output that we see here. Now, I mentioned constant time at the start of this video, and there's actually a couple of different ways to do this one, where one is linear time, meaning if you had a really long file, then it's going to take longer to do because it has to go all the way to the end of the file and then do stuff. Highly suggest you don't use this version, but it is a really good test to see. Like if you had something like, I don't know, a 500 meg video, you can actually compare running these two commands here just to see how much faster the constant time one is. But in this case, we're actually taking advantage of tail, which I did not know up until recently has a -c flag here. So if we go to tail's man pages here, we can see -c, which is the bytes flag here. You know, this is going to output the last number of bytes. And it's like, wow, that's like exactly what we want here. So if we do tail c on python.jpg, oh, you have to put the number in, yep, python.jpg, we're actually not getting any output. Okay, that's kind of interesting. So let me try, I don't know, the Ruby PNG. Yeah, so I don't know, I expected the Python one to output some like, you know, gobbledygook, right? It's a binary file, you can't really do anything with it. In any case though, we can take this output and we can pipe it right into OD and we can be like, you know what, I want to get the, in this case, the first 2 bytes, right? Or the last 2 bytes, sorry, we're doing the last 2 here. So yeah, tail just gave us the last 2 bytes, pipe it right into OD, get the same format that we want before, and now we're back to what we were getting originally with the first 2 bytes, except these happen to be the last 2, right? Because we go back to the notes here, we can see FFD9, those are the last 2 here. So this is super handy. And by the way, like if you wanted to get the last 8 bytes or something, you can just do 8 instead of 2, and there we go. But let's go back to 2 here and just see how that looks here. And that gives us mostly what we want. But then we can just, you know, do the exact same head and cut commands that we did before, you know, exactly the same, right? They're lining up there. And we can run them together, and then we can see that we do get the last 2. So if we go back to just running the script here, how we did before, then there is the last 2 here in both constant and linear time. And cool, so I would recommend using the constant time, right? It's going to be faster. And the other one is, well, let's just use the OD commands. And this time we're not going to use any -n flag because we want to get the whole entire file here, which is going to be a pretty big output here. You know, we could see there's just like, you know, a lot of things. So yeah, but the last 2 are just hiding right there. So then we can just be like, well, okay, cool. Like, well, I guess we can just use tail and 2 on that one. And then we can get the last 2 lines there. And let me make sure I'm not hiding anything here in the way. Yep, there we go. And then it's like, well, actually though, what we really want to do is just get the last ending of there. And as far as I know, and you know, correct me if I'm wrong here, I don't think cut has a way to be like, go all the way to the end, but then just give me the last 2. And I'm sure I could have cut this where like, you know, specifically this amount of spaces here, like hard coding that in, but I actually was not sure if there was more columns that can never appear here. I think there might be some other OD flags to control that. I don't know. I've only really used OD a couple of times for little one-offs, but in any case, one way to like, maybe get around that is just to like reverse this, right? So that now the last 2 are actually the first 2. And then it's like, well, after we reverse it, right, what could we do? Well, then we can just cut it on a space and then get the first 2 here. You know, in this case, we want to get 9D and FF. We don't care about the rest. So we're using that -2 instead of +2 there. And then we get that. But then it's like, yeah, but the last 2 bytes are really FF 9D, not 9D FF. So what the heck? Let's reverse it again. So this is like wildly inefficient because it's like, you know, reversing and cutting, reversing, blah, blah, blah. But in this case, it's like, you know, such a small string for this stuff. So like, you know, this is not really taking a long time. What's taking a long time is waiting for OD to scan the whole entire file just to pipe it into tail. That's why using tail like this is a lot faster constant time. Nice. So yeah, that is the use case of using OD. Now, when would you actually want to use OD instead of using Python or Ruby or whatever programming language that you want? I don't know. I do have a couple of use cases where I just wanted to check to see if a file type was what I think it was. And, you know, just running a little OD command off the top of my head to get that little output and comparing it to some hex value that I happened to know or know was pretty good. It actually came down to a GZ file. I just wanted to make sure that it actually started with these, which I just found from Googling as needed on an ad hoc basis. Nice. So yeah, let's take a look here at the Python and then Ruby scripts to see how they work. So let's start with the Python one. And I just do have a couple of, you know, JPEGs, or I have one python.jpg and one ruby.png here. But yeah, let's go and see how this works here. So let me go and run Python 3. And that is going to be demo.py. Yep, and in this case, I just decided to go with the first 2 bytes and last 2 bytes. And this is constant time, by the way, for the last 2. But yeah, with Python, we can just open the file, and we are opening it up as a binary file. And then we just say, you know what, let's just read the first 2 bytes here and convert it to the hex format here. And that's what we see. Now there is no space there, but fortunately, if we actually go to the Python documentation for this hex function, which by the way, you will need version 3.5 or above. I really hope you're running that by now because that has been end of life for a really long time now. It's available basically on any distro by default, unless like you're living way, way, way in the past. But there actually is a nice little separator command that you can use here. So if you wanted to have it separated by spaces, you could do that. If you want to have it separated by commas for whatever reason you need to, then you can do that as well. But in this case, if you don't put that in, then yeah, you just get this over here, which is no spaces at all. But yeah, pretty straightforward, really not too bad at all. And then getting the last 2 bytes is basically the same thing. We're still opening the file as a binary file here to read it. And then, you know, we're printing out 2 bytes as hex format. The only difference now is we're actually seeking to the end of the file, which is what this 2 is. And we're going to look at the docs for a sec on that one. But, you know, the goal here is like go to the very, very end of the file, which is like a shortcut for that. And then we're going to go back 2 bytes because we're at the end of the file. Let's go back 2. And then since we're at that location in the file, then we can just read those 2 bytes. And read at this case doesn't care that we're already like negative 2 bytes from the end or the first. Like it just knows to read 2 bytes. So this actually works out pretty nicely. It's a very incremental change, right? So everything is the same except that we're seeking over here. And actually, I don't think I have the Python docs open for seek, and it's probably not going to be easy to find. Is it OS base seek? Maybe it is. Oh, cool. Okay. So there really is a constant that you could use like os.seekend or 2. So in this case, like 0 will start at the start of the stream. That's what we saw over here when we don't put in, well, actually, we're not even using seek. So yeah, that's a start. But in this case, you know, the current stream position, I don't know, if you're inside of a loop somewhere, you can keep track of that and, you know, relative current position. And then also, yeah, the end of the stream is the end. So, you know, you could theoretically, or probably will, if, let's just see if this works. No reason why it shouldn't. But if we import OS here, and instead of using 2, we can actually just use OS seek end. We should get the same output there, and we do. Now, I like this. This is a little bit easier to read because, I don't know, this 2 here is like what? Like it's like a magic number, like a floating, you know, a number that's a little bit harder to understand. But yeah, you can feel free to use whatever one that you want here. But that's how that works with Python there. And the Ruby version is very, very similar. And you know, logic-wise, it's the same thing. So let's go and run the Ruby version, which would be demo.rb. And in this case, we are getting, oh yeah, okay, because we're dealing with a PNG file here. So if we look at our little notes here for a PNG file, this actually starts with 8950, and what we get here is 8950. So this is working in the exact same way, but let's actually confirm that just to make sure. I know it is, but, you know, keeping myself honest here, on video at least. If I can type in python.jpg, okay. And I know this code isn't like mega optimized. Like, of course, I could put that into a variable to not duplicate it, but this is just a demonstration throwaway script, right? But in this case, you know, we can see our bytes there. But let's go back to the Ruby PNG version. And there we go. So I don't have a note here for the last bytes of a PNG. I mean, what I found Googling was, you know, PNG is really looking at the first 8 bytes, not the last, but I included the last here because I just wanted to be able to, you know, demonstrate actually how to do that. So, you know, this is the first 8 bytes over here. And, you know, if you look at 0A at the end, 0A, and then we have 1A, which is over here, and there you go. I actually don't know offhand if Ruby supports unpacking with like a separator or something like that. We're actually going to look at their docs in a sec, so maybe it does. But before we do that, you know, in this case, let's just go over some of the code here, right? So in this case, we're just making a new file here, Ruby PNG here, and we're just going to read however many bytes that we want. In this case, let's read 2 bytes, right? And then we can use the unpack method, which is going to give us back the hexadecimal format here. You know, it's very similar to the hex function in Python. And then the star basically just gives us those bytes. I don't know exactly what happens when you don't put it in there. What do we get back there versus this one? I don't know, maybe it gets all the 2 bytes instead of just the first component of the byte. I'm actually not 100% on that. Let's see what the last one. Last one was 6082. Does this return 6 now for this one? Yeah, so I guess that's what that does. So if we just wanted that, you could do that. And then, yeah, so let me go to the Ruby method here for seek. So in this case, well, actually, let me jump back to here. So yeah, the seeking functionality is very similar to Python here, where you can just seek back 2 bytes here. So yeah, we can see here too, like that's really just an alias to IO seekend. Cool, you can use either one of those. That's going to work the same way. But you know, I just went with end in this case here. Pretty nice. But yeah, let's go to this unpack command here. Is there a way to actually unpack this with a custom delimiter, like for example, if we wanted to use a space or a comma, it is not looking like that. Maybe it's, I don't know. In any case, not super duper important here. Yeah. Feel free to let us know in the comments if you know a way to do that offhand. Honestly, I did not go deep dive on this one. I've actually implemented this a couple of times in Python. The Ruby solution, no, but I wanted to include both because, I've been working with Ruby a little bit more recently, building some web apps for clients there, and I figured just as a personal challenge for myself, I did it in Python, or previously did it in Python too, and was like, okay, let's make a Ruby version 2 just to see how they both compare. And there we go. So yeah, that's going to do it for this video. Sort of a quick one-ish, not really 16 minutes, whatever. But in any case, pretty useful when you need it, right? Just look at the first and couple of last bytes of a file, figure out what they need to be. You can compare against that. But although funny enough, if you're working with a web application in Python or Ruby, there are some really good image processing libraries that probably have little shortcuts to where you don't need to worry about looking at, specific byte sequences. They may just have some function or method where it's like, is JPEG or is image or something like that, and it will go and do the low-level details for you. This way, things are a little bit easier for you at the application code level. But yeah, with that said, let us know in the comments below if you have any questions. I'll do my best to answer all of them. And if you like the video, please give it a thumbs up because it really does help a lot. Thanks for watching, and I will see you in the next video.